So let's picture this out through this example. It says that we are to determine the numbers at which the given function is continuous. Unlike with my other questions that would be asking if it's continuous at a certain number, this time let's check if you are able to have the other way around instead. That is, you have to give me the numbers where it will be continuous. Okay, so how to do this? So first, since we're talking about here composite functions, although we have here just one function, so gives us a hint that we have to somehow separate this function h here and try to have two functions instead. That we will try to do the composite function of these two functions. It will result to the square root of 4 minus x squared. Right, so let's have this one. We can actually let f of x in here be equal to square root of x and have another function, say g of x, be equal to this time 4 minus x squared, so that we'll have something like f of g at x, or that would be our h of x this time, to be square root of 4 minus x squared. Right? I hope you can remember still composite of function that f of g of x here is definitely equal to square root of 4 minus x squared there. So now we have a function f, and a function g. So let's try to make use of these two theorems right here to determine the numbers at which this function would be continuous. Now, let's try to investigate each of the functions here that would be f and g. Let's have some observations. Note that g of x is continuous everywhere, right? That is, we won't have problems actually with g of x when it comes to continuity, because this will just be 4 minus x squared. We can have any number to be substituted at our x here, and we won't have, undefined terms, or undefined answer, or we won't have imaginary numbers, things like that. As a hint, what would try to restrict you from having continuity can be square roots or nth roots, right? Because if the root is even, so square root, 4th root, 6th root. So if we have a negative number inside the square root sign or the nth root sign, that would be the radicand, then definitely our answer would be an imaginary number. So our restriction here. So another restriction would be if we have a denominator to be equal, or would be equal to 0, right? So in that case, we'll have some, consideration for continuity, just like the vertical asymptotes. We'll have some asymptotes considering some domains and range later on. So in this case, going back to our function g of x here, clearly we won't have restrictions here, right? It's just a quadratic equation, so we won't have restrictions. What we might have problems with respect to continuity would be for the function f of x. Notice that our function f of x here is a square root of x. And as I mentioned earlier, we shouldn't have a negative x, right, in this case, or else we'll have imaginary numbers. So we'll have discontinuity because imaginary numbers wouldn't exist in this plane, in an xy plane, in a real numbers plane. So in that case, let's write the restrictions here that our f of x is continuous at what? At every positive number, right? We can only consider positive numbers for f of x here. And so applying this theorem right here with the statement that says again, if the function g is continuous at a and the function f is continuous at g of a, the composite function f of g is continuous at a. Now notice that our f of g again in this case is h. Now the placements of our f and g would be just the same in here. So let's have further notes here and say that, and conclude actually that h in here, 4 minus x squared, is actually continuous at every number where our g of x would satisfy. In this case, that would be greater than 0. So where g of x is greater than 0. And so, since our g of x is actually equal to 4 minus x squared, I hope you have not forgotten that. So in that case, since 4 minus x squared would be our g of x, substituting that one here, we'll now have 4 minus x squared, which is greater than 0. Again, we're trying to look for the function, the numbers where this function is continuous. Solving this inequality 4 minus x squared greater than 0, algebraically, that's 4 minus x squared greater than 0. So let's transpose x squared, so that gives us 4 greater than x squared, right? Applying square root to both sides of the inequality, so our x would be a positive or a negative 2. There. So in this case, h is continuous at every number, still every number. It says that where this happens, and it happens that this would happen at this. So that would be at every number in the open interval -2 until a +2. Ma'am, why is it open interval? Open. So meaning our -2 and our +2 wouldn't be included in the numbers that would make this given function continuous. Careful, because it says here that x must be greater than -2 and +2. Careful, it says that our x here is less than a positive or a -2. So when can an x be less than a +2? So if 2 is here and we have a -2 here, where will our x be? Definitely our x would just be in between interval -2 and +2. So as for the open interval, -2 and 2 are not included because we don't have equal symbol here, equal sign. That would denote and connote the inclusion of -2 and +2. Okay, so I hope this one is clear for you guys. Just in case this isn't that clear for you, then definitely you may comment down below what your issues are, and I'd be more than willing to help you answer that. Alright, thank you for watching and listening to this video, and I hope you'd be prepared for upcoming practice and exam. Alright, see you guys.